Hello everyone. I welcome you all to this session on input-output ports of PIC16F877. So PIC16F877 is an 8-bit microcontroller. It has input and output ports in order to access the controller. So we are going to discuss about the port structures available and about the pin details of the port structures. So let us look every ports individually here. So if you see PIC16F877A, it is a 40-pin IC. It is an 8-bit microcontroller. This microcontroller has 33 input-output pins. This 33 input-output pins are included in 5 ports. So, whenever we start with programming a microcontroller, we need to give the supply, the ground and the reset. So, we have to know about the pins of that. So, pin number 1, it denotes the reset pin of a PIC16F877A. Similarly, pin 11 and pin 32 defines the VDD or the supply, and PIC16F877A it requires plus 5 volt supply. Next, pin number 12 and pin number 31 as shown here are ground pins. Next, coming to PIC16F877A, it requires external clocks. So, 2 clocks are available which has to be accessed or enabled by pin number 13 and pin number 14. And coming to the port pins. So, as already I said, totally 5 ports are available with PIC16F877A or PIC16F877. Both has 5 ports, and altogether 33 pins are available, or 33 IO signals or pins are available. So, out of which port A has 6 pins. Out of the 33, port A holds 6 pins, that is from RA0, RA1 to RA5, which has the pin number 2 to 7 respectively. So, if I want to access the port RA0, then I have to enable the pin number 2 of this microcontroller. Similarly, if I want to access RA4 of this PIC, then I have to enable pin number 6 of this microcontroller. Similarly, this is port B. So, port B has 8 pins. So, altogether RB0 to RB7, 8 pins which extends from 33 to 40, pin number 40. All these pins are multifunctional. Other than this IO input-output ports, it does different functions also. Now, we are focusing only on the ports, so I am discussing about these ports. Similarly, port C. Port C is also a 8 pin port. That is, it has RC0 to RC7. RC defines C as port C. So, RC0 to RC7, altogether 8 pins are there. Among that 8 pins, pin number 15 to 18 and then pin number 23 to 26, 4 on this side and 4 on this side constitutes port C. Then again port D is an 8 pin port. So, here pin number 19, 20, 21, 22 and 27 to 30 constitutes port D. So, for port D also we have the signals RD0 to RD7. Then finally comes the port E. So, in port E it has, so now if you add all together, port A has 6 pins, port B, C and D has 8 pins each, and so altogether 30 pins are over, and the remaining 3 signals or 3 pins will be there in port E. That is, it constitutes pin numbers, pin number 8 to 10. Again, see, pin number 8 to 10 has different other functionalities too, for reading or for writing, or for all these we'll be using this. Meantime, it is being used for IO ports also. That will be enabled or disabled depending upon the digital signals which we are giving into. So this is a complete diagram of signal description or a pin diagram of the microcontroller. So everything has been included here. That is, pin number 1 is a reset pin. Then here we have the port A pins. Then we have the port B this side. Then we have port C this side, and port D half here and half here, and port E 3 pins here, along with the VDD supply, 2 VDD and 2 supply are there, and 2 clock signals are also there. So in order to access the microcontroller's input and outputs, we need to know about the pin details or signal descriptions of these IO ports. So I hope this explanation gives you a clarity on all the ports of PIC16F877A. So how many, this is for your self-assessment, how many IO ports does port E has, as well as how many clock pins are there in PIC16F877. It has external clocks, so how many are there? Thank you.